There is no other facility in the world that provides this size for testing with the movable floor and all other sensing and instrumentation equipped with the digital tools that complement the physical modeling.
The National Buried Infrastructure Facility opened 2022, and it's one of several facilities that were built under a UCRIC scheme, which UCRIC stands for the UK Collaboratorium for Research on Infrastructure and Cities. And as such, 14 founding universities got together, lobbied government that we really need to have a collaborative research capability in the area of infrastructure and cities. And as part of this, we built the National Buried Infrastructure Facility at Birmingham, because the idea was that each institution really expanded their strengths, and our strength at Birmingham has always been on buried infrastructure, our pipes, cables, sort of geotechnical engineering, anything to do with the soil. That's where our strength was, and as a result we built NBIF. So the sectors we've dealt with are probably mainly the civil engineering construction industry, but in its broader sense, so from the supply chain to the contractors to the consultants. Anybody who really wants to break ground, has got assets in the ground, and wants to place something on top of the ground, because the ground is potentially the highest risk in any construction project, but also provides the biggest opportunity, because we can look at ground source heat pumps, all these alternatives that we want to use our underground space for. One of the key facilities that doesn't exist anywhere in the world is our movable floor. This was built in collaboration with MTS, which comprises our 50 actuators, but we also have a number of other actuators to simulate our surface loading, both as static as well as dynamic actuators. And if you're wondering why did we choose MTS, because we actually did have experience with using their systems in the past, so therefore we were confident that they were sort of our delivery partner to develop this together.
When we do an experiment in NBIF, we always equip it with advanced and state-of-the-art sensing technology. That data that comes out of the sensor then are used to build a replica for the experiment, a so-called digital twin. The difference between the digital twin and a standard static numerical model is that the digital twin can get data in a live format, which then allows you to build your simulation in real time, which then allows you to tell about the status of your experimental setup and make changes or stop it or update as and if needed. We also use machine learning to extend beyond the current scenarios in order to predict what happens under various different conditions, be it environmental, be it physical, be it mechanical.
We are simulating the frequent passage of HS2 trains, our high-speed trains, over our pipe. It is absolutely invaluable to us to understand the exact stresses and strains and deflection when the various scenarios are played out. There are very, very few other facilities in the world that can achieve that.
I always think of NBIF as a big Meccano set, which you can adapt. And if we can do it at smaller scale, we will do it at smaller scale. We don't have to use the large scale. What's important is that the end product, the data we get out of these experiments, is meaningful and helps address the question. We have done a number of experiments to date. These range from looking at pile foundations, where we constructed the piles using two different methods. We've looked at displacements of a tunnel. We used a pipe to simulate the tunnel. We have tested some structural beams. We are planning to do a platform test where we look at platforms for construction vehicles on quite soft material. But we've got plans in the future where we're trying to look at tree root soil interaction, so something completely different. But because we have got the scale and we've got a way of loading it using our actuator system, we can do this in our facility, and that couldn't be done anywhere else, because we can do it in the field, but we just can't control it in the same way as we can do in NBIF. What really excites me is that we can do something that ultimately feeds into industry and changes the way we do things. So whether that's sensing technologies, whether that's methodologies or processes, we will be able to support industry to make a step change and really change things for the better. Being a civil engineer, I have a civic responsibility, and we can really use NBIF to its fullest potential for this.